We've now added tuples, generalization of strings, an ordered sequence of elements, where the elements can be any structure. And we've already seen that a lot of the operations we wanted on strings we're going to have on tuples. We're going to add another kind of structure called a list, and it looks a lot like tuples. Again, lists are ordered sequences of values. Each one's identified by an index, so it's going to support all the same kinds of operations I saw before. The difference here is that we're going to use these square brackets rather than the parentheses to distinguish a list, or to create a list, as opposed to a tuple. So they got a little difference in terms of how they're going to look. And as a consequence, one nice thing is that singletons are now pretty straightforward. It's just a square bracket, the entry in another square bracket. I don't have to put that annoying comma in that I had to do with tuples in order to distinguish between an arithmetic expression and a tuple with just one element. Looks much the same, so what's the big deal? Well, there's one very big difference, and it's a really important one, which is that lists are mutable. And what does that mean? It means we can change them. What does that mean? Well, things like ints, floats, strings, and tuples are immutable. And that means that we can't go in and change an element inside of them. Now, for instance, floats, that's obvious. In tuples we just introduced, so we sort of have to accept that on faith. But if you think about strings, you can get elements of strings out, you can slice into strings, but you can't go in and directly change one character in a string. They're not mutable. They're immutable. They don't change. On the other hand, lists can be modified after they're created. And why would we want to do that? Well, in part, because there are going to be some problems where that's really valuable. So what does that mean? Some data objects we really want to treat as if fixed. It says we create new versions of them, we can bind variables to them, but we don't want to change them. And this is usually valuable when those data objects are going to be frequently referenced, but where the pieces inside of them don't change. Why would we want to support having ability to change them? Because that can just lead to bugs. On the other hand, there's going to be some instances where the data objects may want to support modifications to elements inside of them. Why might that happen? Imagine you've got a really large database of personnel information. You want to do things like change salaries. You don't want to have to make an entirely new copy of the database just to add in a new salary. You'd like to be able to go inside and change a piece of that. So, lists are going to support that kind of operation by enabling us to go in and mutate or alter elements of the pieces. One issue to keep in mind is that while mutable structures give us more flexibility, they also are more prone to programming errors. If I've got two different pieces of code, both pointing to the same list, and I have one piece of code change or mutate a portion of the list, I want to make sure that that other piece of code is aware of that. If not, I can get myself into some really interesting bugs. So, there's a cost, but there's a bonus. All right, let's look at an example of what this means. So let's create a couple of lists. And in fact, over here in my idle shell, I'm going to do that. Let me just create a couple of lists. And I'm going to call TEX as a name for a couple of great technical schools. And notice the angle braces to get them for me. And I'm going to create IVs. I'm not going to do all of them, but I will again create a list of some great schools. We'll do Harvard, we'll do Yale, and we'll do Brown. Okay, and if I print them out, I can say what is the value of TEX, and it just gives me that list. On my slide, I've given you a visualization of that. So think of this as TEX and IVs sitting up in that global environment. After all, I just typed them into the shell for Python. And what do? Well, they point to a structure in memory somewhere that has that sequence of elements inside of it. As I've said, I can treat this as if they were just ordered sequences. So I could say something like, what is the first element of the IVs? Remember, we start indexing at 0, so that gives me back Yale, which is nice. Then I could slice if I wanted to. I could say, give me back the IVs, everything up to the second one, and that gives me the 0th and first element. So I can do things I'd expect to do on that.